Welcome to the Machine Learning at Home. Today I will speak about distances. There are lots of different ways to calculate distances because there are so many different data objects. There are, for example, very complicated distances, or very simplistic distances, or specialized distances which work only in particular fields of data science. Today I will show you the examples of all three different kinds of distances: complicated, simple, and specialized. And they are available in my packages. So first of all, we will load one of them. So main package is library Shipunov. And now I will give you some complicated example. First of all, we now need to create the data. Data will be created step by step. So first of all, I will create 4 different vectors. Then we'll gather them in one data frame. So first vector is x1, and it will be logical variable. As logical are binom, which is binomial distribution, with some parameters, and I need 7 numbers only. And x1 will be just truth and false. In that case, they're all truth, for example. Now I need second column, which will be some symbols, characters. So I will sample from letters, and I will need 7 different letters, and will allow replacement. So x2 is now some letters. Now I need some numbers. It will be very simple. I will simply take normal distribution, norm, and ask to give me 7 numbers. So x3 are 7 numbers. Finally, I will need x4, and x4 will be ordered factor. Not frequently used, but useful type of data which will contain some ordered values. So this is from ordered function, and within I will put cut, which will create factors, and I will simply cut already existed variable x3 and cut it with levels from -3 to 3, and will also ask to include the lowest one. Okay, sounds like it's correct. Now I need to show what is it. So as you see, these are factors ordered in some particular way, from the lowest, from negative side, to the biggest, to the positive side. And finally, I will create the data frame. We'll call it XX, and data frame x1, x2, x3, x4, and xx looks like this one. So it contains 4 columns of completely different nature. So normal distance methods will not work with this kind of data. We need something else, and that something else is, for example, Gover distance. So Gover distance is a way to calculate distances from data of different nature. So we simply apply it here, and we'll create some distant object. So these are distances. So Gover distance will eat almost any kind of data and will take into account the nature of each column. So for each kind of data, it will apply slightly different methods of calculating distances. And you see, result will be similar to normal distance. So we can even plot it. For example, we'll plot it as hierarchical clustering. So this is a cluster diagram of our, well, artificially created data. So use governor distance in case if your columns in a data frame have different nature, like in that case. For example, some of them logical, some of them numbers, some of them characters, some of them ordered factors or simple factors, or any combinations of these types. Now, different kind of data. So we might simply ask R to calculate distance with very simple method. For example, the row 5 and 6, they match each other very well, except for column number 3 when numbers are different. But all other columns are similar. So maybe we can kind of employ the coefficient, which will simply compare if values in each cell are same or not. That's called simple matching distances. Very simple distance indeed. So we can apply it to our XX data. SM dist XX. So as you see, results are again simplistic, and since column number 5 and 6 are really similar, the distance between them is very small, 0.25, the smallest distance of all. That's quite logical, and we can of course create the same hierarchical clustering from simple match distance. So this contains less information because that distance only takes into account the full correspondence, only if cells are just the same or not the same. So you can use simple match distances. You see, it's also universal, like a governor distance, but will retain much less information. And now the third kind of distance. That distance is called taxonomic distance. It was invented for specific biological kind of data and might be used, for example, in biological taxonomy or in ecology. So we'll use it for ecological data. So first of all, I will load one of my small packages. Library Smirnov. So if you don't have it, please install it. It's very easy. You simply need to type install packages, and don't forget quotes. In that case, you must have quotes here. But I will show you that command, but don't run it. So if you don't have Smirnov, please install it. I already have it, and I already load it. So again, when you install it, don't forget to load it with the command library. And now we need a data. That data is a data about some plant species which grow on islands within a lake. So interesting, funny data. So that data looks like, you see on the left side, row names are names of plant species, scientific names of course, and each column is just one island. And numbers are just some characteristics of presence. 0 means absent, 2 means some small number of plants, 3 means a bigger number of plants, and so on. I will transform it to just a binary data because Smirnov distance wants only binary data. So I will first transpose the data, and then I will make them binary. So this is what is going on. I will first of all use function Smirnov, and will apply it to T, transpose it, because I want distances between islands, not between plant species. And by default, all distances will calculate distances between rows, not between columns. And I didn't make it binary right now because Smirnov inside will make it itself. So it's safe enough to run it like it. So all values bigger than 0 will be converted into 1. And then I will simply say it will be M1 SM, for example. Okay, I made it, and now I need to make it similar to like a normal distance. So for that reason, I will calculate difference between 1 and calculated distances. So I need to say m1 as d will be 1 minus m1 sm. So why is that? Because by default Smirnov calculates similarities, but I need distances, dissimilarities. And then I also need the names of islands to be retained, so I will apply function dimnames to m1 as d, and then we'll take list of names of my Moldina data, and that will be dimnames of my distances. Finally, I can plot it with the same hierarchical clustering dendrogram, but before plotting, I must convert it to specific for our distant object. So finally, some mini operations required, as dd will be as dist m1 as d, and we can plot it now. So plot hclust m1 as dd, and now you can see different islands. So some islands are more distant, like this left cluster of 2 islands, and some islands are much closer together. Some of them, like Knuti and Leda, are even very close to each other. So this is one of results, very interesting, useful, and maybe good for some particular publication. Now Smirnov has one more interesting option. It can calculate uniqueness, unusualness of each object. Very useful and interesting. So for that reason, I will return to my m1 sm object back again. So this is 1. And we'll take out diagonal of it. So m1, I will call it txx, and we'll take diagonal from m1 sm for it. And again, I need some names to be retained, so I will take names of m1 txx, and we'll put these names from my names of initial object Moldina. So these names will come into m1 txx. And now I simply need to show you what's going on. So I will simply sort in a reverse way rounded values of this m1 txx, only for visual purposes. So I will round m1 txx with 3 digits, and we'll sort it. By default, our sort in increasing way, but I need a decreasing way, so I will reverse that sorting. Okay, and now you can see which island is most outstanding. This is a Varick island, which has the highest value of uniqueness. So this is very unusual and might be useful for the research. Uniqueness, outstandingness, whatever you can call it. So 3 different coefficients, 3 different ways to calculate distance. Gavr distance is absolutely universal and applicable to any type of data. Simple match distance is also universal, but only calculates if cells is identical or not. And finally, biological Smirnov distance. That was 3 distances I wanted to show today. Thank you very much.